Hey everybody, Mark here, also 2 Robot Guy, with a quick update on the NASA GrabCAD challenge that was posted on GrabCAD. Wanted to kind of go over since yesterday of some of the designs I've been going through and some of the successes and pitfalls that have occurred. So. If you guys have seen my previous videos, I kind of talked about the process design, about how I got to this idea. But just to do a quick recap, um, I've seen a lot of designs online that were snap fit. I wanted to go in a different direction to give a more mechanical fit to the part. So I actually went with it's a buttress style thread. You might be able to see that it's considered a buttress style thread. There are 4 fans or 4 blades to this one, and it just slides right in place. And what's really cool about this is you can just do really small turns, and it will lock right into place. So that was actually Gen 2 with this buttress style thread, and you can see it's kind of a beast here. But it gave me some proof of concept about how this works and how I can make it better. So that was the first one. So with information on this, I went to a slightly thinner design. Instead, I went to 2 blades instead of 4 blades. That gives me more of a rotation, and actually has a longer throw on it to be able to pull the threads in. This came out to be a great design. It was wonderful. I was so excited about it. Let me show you how it works if you guys haven't seen it. But pretend right now that is the handrail that one of the astronauts would be grabbing onto to put their, let's say, state-of-the-art camera or a research thing, and they would just go and slide. This actually is 3 pieces, but they would just go and connect it like this. The rail wouldn't move, and all you'd have to do is pull it down, and once it's pulled down, it is tight. It is not going anywhere, and that is just great. It is really, really tight. Man, I was so excited about this. This was a great design. After I posted it, I got some bad news. Jonathan on the forum said, did you measure what your offset is here? In the rules, it said when it's down, it needs to be within an inch. Oh, I pull out my tape measure, and sad to say, we are sitting, if you can see that, at about 1.25 inches. Even farther here, we're more 1.5 inches. So we're outside of it. This one, it does work. They could print it up in the International Space Center, but it doesn't fall inside the criteria, so it wouldn't even be accepted into the contest. I was pretty taken back when I designed this, and it wasn't going to work. But with every, you learn more about the design when you fail than when you succeed. If you succeed, you just don't know. You just don't know why you succeeded. I mean, you could assume, but when you fail, you know why you failed. I'm outside of the parameters. So I went back to the drawing board. I said, okay, how am I going to make this smaller? So I'll unlock this. How am I going to make this smaller? I kept on asking myself, and I looked at the model, and I came back with this little gem, man. This is just, it's 20% smaller, or 20% less volume. So it's a smaller print. It's just as strong as its big brother. It is pretty close to identical copy of its big brother. I use the same model, but I went and changed some stuff about it, and you can see right here. See right there? This is a 20 millimeter threaded or buttress rod. This over here is a 16. So 4 millimeters difference, or 2 millimeters off the radius, made a huge difference. And you can kind of see. Let's kind of go through it. But thickness wise, Look how much thinner that is. It's so much thinner. And it works. Let's go here. Where can we? So we did this one. What other thickness can we do? We can look at that, man. Look how much thinner that is. It is. So when you can decrease the size like this and bring the threaded rod in closer, you do a couple things. When you can decrease the diameter of this, you don't just save in one direction. You can save in two. And this would be the X and the Y. Now the Z is the same length because of the size of the handrail. So I can take a little bit off of Z. But it gave me an opportunity to redesign something. You know, the design's never perfect. Another thing you can notice, Gen 3 versus Gen 4 is the handle's a little bit longer. It's actually 10 millimeters longer. That will give the astronauts a little bit better mechanical advantage. If they're up there with gloves or, you know, maybe there's something else in their hand, it would be easier to grab onto a little bit longer of an arm to do it. But when I had to bring this in, I'm a big symmetry guy, but there's no way to keep the symmetry with where the T-rail is. It is actually about 4 millimeters off center now, coming in this direction, just because of trying to bring this in as close as I can. I mean, it is really, really, really close. You can see, look how thin that wall is. It's really thin, but I still have all the strength I need to make it work. So let me show you how it's going to work in the International Space Center. But the astronaut's going to get their rod, and it's going to be, you know, it's going to be pretty long, right? And they'll have both their pieces like so. And all they have to do is thread it in. There we go. And bring it down. And it's tight. It is really tight. And you can even bring this down a little bit more. How it works is that thread is really pinching in on it. It works as a fulcrum point off this back edge, and it fulcrums this in. So this is the new design. I have this posted now, so check it out. Print it, try it. I have a SolidWorks file as well as a step, so you can kind of see how I did the threads. I've posted about the thread pattern and how I went and designed them. So if you're looking to do the Buster style thread in your design, you know, I'm happy to share any of the insider information I've done with this thread design. But I was thinking, or actually I was playing with this a little bit, and I found something amazing out on this one. I haven't seen this in any other design. And this was by luck. This wasn't by design. I lucked into this, but it is really, really cool. So watch it. So as we know, if we put this thing to 90, it's fine. It's, you know, everything will come apart. You know, this thing will come right out. This thing will go right back in. Cool, right? But what if I go and put it up? So you would say, Mark, what does up would do? Wouldn't it make it looser? Well, it does. But look at that. You can slide it anywhere on the rail. So it doesn't interfere with this. So you theoretically can, oh, here, I'm sorry, I'm stuck on my poor printed part. But theoretically, you could put your laptop or your camera or whatever they have up in space right in there. And let's say it was somewhere on the rail, it needs to be slid over just a little bit, or, you know, better for them to have their clipboard or their pen somewhere else. They don't even have to take it off. They don't even have to take it off. They actually could leave it semi-clamped on now, slide it to the location they want, twist it all the way down, and there it is. It's locked on. I mean, it is locked on. So it's just by luck. I would like to say it's by design. I guess it is by design because how it's built. But that is really cool. I have not seen any other design that can do that. And it is a huge advantage. Because being able to slide it up and down, if you didn't lock it in the right place, you can. And you could leave it unlocked if you want to if you had a couple of these, if you were doing some kind of experiments or some tests, you could slide them all up and you could lock one of them down. It could lock the rest of them down without having them locked. So let's undo it one last time to show how easy it is to undo it. All you have to do is make sure that's 90. You can take it apart. It comes in 3 pieces, like so. And you also can send this thing to the up position. One sec. You can set it to the up position. It'll lock it into place, and this can be put in a bag or stored or whatever it has to be. As you guys can also check out on the website, I found a really cool way to print this as well. So because there's an undercut on this, this piece can actually be printed underneath this piece just like that, and this piece can be printed vertically, and it kind of can nestle inside of it. Can you see that? So it can nestle inside of it. This is right at 50 millimeters by 67 millimeters by 51 millimeters. So this little platen is a little bit more than half of the Made in Space 3D printer. But I'm going to go and try to do some more designing and see if I actually can print 2 of these at once in the printer. And that would be really cool because, you know, the astronaut's time is valuable. And if they need more than 1 clamp, they could just print 2 right now. So guys, please try it out. Tell me what you think. I'm always open to new ideas and suggestions. I'm an open source kind of guy. So let's work on this together and make a really cool project. Mark signing off, and I'll keep you guys in the loop.